Have you ever thought about our world, like how everything goes in a rapid pace? Or have you ever questioned things in your surrounding, like why some plants have the ability to grow inside the house and why most of them cannot? How does it happen? There are a lot of questions in our head which most of the time, we cannot answer them right away because to answer that question, it requires us to do something, right? But we can actually do that by doing an investigation like how scientists work. In today's video, we are going to discuss scientific method. We all know that science is a way of thinking and a way of gathering knowledge about the world that is both accurate and reliable. And to identify what things are accurate and what is not, they do the process of scientific investigation or scientific method. Scientific method involves a series of steps that are used to investigate a natural occurrence. There are 6 steps of scientific method. First is observation. Second is question. Third is hypothesis. Fourth is experiment. Fifth is analyzing the results. And the last is conclusion. Now, how we do the first step? Let's set this plant as our example. You are trying to grow this plant because you notice that it's dying inside your house. Now, that is observation. Yes, using your senses is the key to first step. In the second step, which is question, it needs you to formulate a question based on your observation by checking out the things around you to find out everything you can about a problem you want to solve. So based on our example, our question would be like this: will the plant grow better if I put them outside the house? Now that you already came up your question, the next step you'll need to do is to make a hypothesis. When we say hypothesis, it is an educated guess or tentative answer to a problem. In other words, you will predict the outcomes of an action that you will do based on your question. So in order for you to make a hypothesis, identify first the variable. When we say variable, it is the factor, trait, or condition that can exist in differing amounts or types. There are 3 types of variable: the independent, dependent, and controlled variables. Independent variable is the one that is manipulated or changed by the scientist. In our example, what we're going to change is the displacement of place where the plant would be put outside the house. On the other hand, dependent variable is the thing that the scientist focuses her observations on to see how they respond to the change made to the independent variable. In other words, this is what you are going to observe and measure. In our example, our dependent variable is the condition of plant, which is based on what we observed. It is dying. Controlled variable is the quantity that a scientist wants to remain constant. In our example, plant is our controlled variable. Using the same plant in our experiment will result to more accurate and reliable result than choosing another plant, because if you did not, then other explanations could be given for differences you observe in plants. For instance, maybe this type of plant is only dehydrated. Or maybe it's just a plastic that is deteriorated because someone unfixed it. Who knows? So, in constructing your hypothesis, it is important to identify the variables first, as it will guide you to make a measurable predictions. In our example, our hypothesis would be: if I put this plant outside the house, then it will grow better. However, a guess alone does not prove anything. So, in order to be accurate and reliable, you must perform an experiment. Experiment is testing your hypothesis whether it is accurate or not. So, in our example, we are now going to place the plant outside the house. Remember that our independent variable is the changing of location of plant. For a typical experiment, you should plan to repeat it at least 3 times more is better. But in our example, since you are doing something like growing plant, then you should do the experiment on at least 3 plants in separate pots, but make sure that they all have the same conditions. That's the same as doing the experiment 3 times. Once your experiment is complete, collect your measurements and analyze them to see if they support your hypothesis or not. And oftentimes, results of experiments didn't support the predictions, and thus, hypothesis is rejected. And that's why in such cases, they communicate with the results of their experiment and go back again to construct a new hypothesis. So that's why communicating the results is considered as the last step of scientific method, which is conclusion, because it is the final answer to your problem or experiment. Thank you for watching, and see you on my next video. Bye!